In lesson 3-2, our focus is on greatest common factor, or GCF, least common multiple, or LCM, and prime factorization. So what I'm going to show you today in this video is what prime factorization is and how we do it. Because we're going to use prime factorization to help us figure out what the GCF is and the LCM is of different numbers. So the first thing that I want to review is what a prime number is. So we have prime numbers and we also have composite numbers. A prime number is a number that the only factors of the number are one in itself. So for example, 5 is prime. The only two factors that I can multiply together to get 5 is 1 times 5. Another prime number is 7. I can only multiply 1 times 7 to get 7. Another one would be 11. The only factors I have of 11 are 1 times 11. Okay, so that's what a prime number is. It's only the factor of 1 and the number itself. In this case, it's 7. In this case, it's 11. So then we also have composite numbers. Okay, composite numbers are all the other numbers. These numbers have more than two factors. Okay, so for example, the number 12. This number has these two factors to make 12. 1 times 12 gives me 12, but it also has the factors 2 times 6 and 3 times 4. These all make 12 when I multiply them together. So 12 is composite because it has more than two factors. 8 would be a composite number. I can make 8 by doing 1 times 8, 2 times 4, and that is it. But it has more than two factors. So we have to understand prime and composite in order to know how to do prime factorization. All right, so when we do prime factorization, what we're looking for is we're taking a number and we're breaking it down into the prime factors. Okay, so we use what's called a factor tree. A factor tree shows us the prime factorization of a composite number. And there is only one prime factorization for any number. So if I want to look at this example, 12. This is, and we call it a factor tree because it actually looks like a tree. So what are two factors that I know when I multiply them together, it gives me 12. I know that 2 times 6 is 12. I can't use 1 times 12 because I would still have to break down 12. I'll show you here. If I did 1 times 12, that is correct. That is a factor, but I have to break down all of the composite numbers. So 2 is a prime number because the only factor of 2 is 1 and 2. 6 is composite, so I have to continue to break this down until it's all prime. So what factors can I multiply together to give me 6? Well, I know 2 times 3 gives me 6. And the number 2 is prime, so I'm going to circle it. And the number 3 is prime. I'm going to circle it. So I'm breaking 12 down into all the prime factors. So the prime factorization, I'm going to abbreviate it as PF for 12, is 2 times 2 times 3. Okay. And if I'm going to show you over here, if I did write 1 times 12, that's fine. It just gives me an extra step. I have to break down 12. 2 times 6. 2 is prime. 6 is not prime, so I have to break that down. I know that 2 times 3 gives me 6. 2 is prime, and 3 is prime. And 1 is prime. So if I write the prime factorization, it would be 1 times 2 times 2 times 3. And I could include the 1 over here, but I don't need to because anything times 1 is itself. Okay, so that's how we make prime factorizations. That's how we find it. We're breaking a number, a composite number, down into the prime factors. So let's do another example. All right, let's do 20, let's do 24. All right, so if I break down 24, what factors give me 24? And it could be different factors. Someone might say 2 times 12, which gives you 24. And another person, this is person A, and this is person B. Person B might say 3 times 8. That also gives you 24. It doesn't matter which factors you choose as long as they equal 24 because the prime factorization is going to be the same. So let's start with person A. Person A does 2 times 12. 2 is prime and 12 is not. So I have to break down the 12. Okay, what makes a 12? 2 times 6. 2 is prime, 6 is not prime. So I have to break down the 6. How do I make a 6? 2 times 3. 2 is prime and 3 is prime. So person A gets the prime factorization of 2 times 2 times 2 times 3. Okay, now this is person B. Person B, in their head, they knew 3 times 8 is 24. So 3 is prime, but 8 is not. So I have to break down 8. I'm going to do 2 times 4. 2 is prime, 4 is not. So I have to break down the 4. What makes a 4? 2 times 2. 2 is prime and 2 is prime. So this person gets the prime factorization of, and I like to start with the lowest number, lowest value, 2 times 2 times 2 times 3. And if you compare person A to person B, they have the same exact prime factorization. So it does not matter if you use the factors 2 and 12 or 3 and 8, or it could be something else. As long as you break them down, each composite number, and you break it down to their primes, you will have the same prime factorization. So I'm going to do one more. Let's see. Let's do 32. I want to break down 32. And please always draw these little, like the caret, the arrow, because it helps you see. I know that 4 times 8 is 32. 4 is a composite number. It has more than one factor. So I'm going to break down 4 to 2 times 2. 2 is prime and 2 is prime. Now I have to break down the 8. Don't forget it, because even though it's up here, we might forget it. I'm going to break that down into 2 times 4. 2 is prime, 4 is not prime, so I have to break down the 4. 2 times 2. That's prime. So my prime factorization for 32 is 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2. So this is what we're going to be practicing today, is just finding prime factorizations of the composite numbers, because this is the first step in figuring out our greatest common factors and our least common multiples. So this is what we're going to be doing today, and you're going to be working on a worksheet that you're going to hand in.